Okay, so this is the last page. There are only 24 problems on the study guide, so probably throw in hopefully an easy question for you. Some of the problems, that are quick and easy and maybe easy to remember. Some are longer and a little more involved, more complicated, but make a good page of notes, study this video, watch it, watch these videos to get a good feel of the study guide. Okay. So they want us to solve the equation. Well, we can write this in terms of exponents because 27 is 3 cubed. So we can say 3 to the 4x minus 5 equals 3 cubed. Now this is that idea of 1 to 1 where we pop out the exponents and set them equal to each other. So I'll briefly explain this. You're not doing anything to both sides of the equation. You're using this idea of one-to-oneness. If you have 3 to some power and it equals 3 to some power, those powers have to be the same because the bases are the same. So you're pulling those powers out and making a new equation where you're setting the powers equal to each other, powers or exponents. Now, this is linear. With that, we can solve. We add 5 to both sides. 4x equals 8, divide by 4. And we get x equals 2. Now, this is an exponential equation. There's no restrictions on x, so you can just put a box around it. Okay, so here we have an equation. We want to solve for x. It says give exact answer. That means we're not looking for a decimal approximation. Okay, the first thing you want to do is isolate the base, and in this case, the base is e, so you're going to divide both sides by 4. That is going to make your life easier. So e to the 3x equals 125 if you do that division. Okay, now where is the variable? It's up in the exponent. The x is in the exponent. Okay, so the base is e, so it's best to use a natural log here. So natural log of 125 equals 3x. So this comes from e to some power equaling y. You can change that into natural log of y equals b. That should be in your book somewhere or something like that. But it's the same principle of just changing exponent to a logarithmic equation. It's just that the base is already e, so that's why we use natural log. You could write log base e of y equals b, and then change that to natural log because it's base e. Okay, we're almost done. So we're trying to solve for x, divide by 3. We're not doing a decimal approximation. We're doing an exact answer. So we're just going to put natural log of 125 over 3. We're going to put a box around it. This long explanation in the middle was to remind you how to change from an exponential equation to a logarithmic equation. Okay. Similar problem here. We want to get x, well, kind of similar. We want to get x, we want to solve for that, but it's in the argument, and you can't just pull that out. So first, isolate the logarithm. Subtract 3. You're going to get 4 natural log of 2x equals 12. Divide both sides by 4. Yeah, and you get natural log of 2x equals 3. I feel like there's a lot of the same numbers running around here. Okay. Now you want to take it out of logarithm and go back to exponential. So what's the base? Base is that e that you can't see. E to the third equals 2x. So how do you solve for x? Divide by 2. Remember, we're looking for an exact answer here, so we're not going to get a decimal approximation. E cubed over 2. You could put that in a calculator and get a decimal approximation, but they ask for an exact answer. So that's the answer. Now those really aren't too bad after you do a couple of them, hopefully. All right, so this is our last problem here. How long will it take 12,500 to grow to 20,000 at an annual rate of 6.5% compounded quarterly? Okay, so we need that one formula. Round to the nearest year. So we're looking for time. We're looking for the t. So that equation, we had it in the last video, or the video before, I don't remember. It was this one. And we know the amount we're trying to get. We're trying to get 20,000. We want it to grow. We want our account to grow to 20,000. The principal, what we're starting with, is 12,500. You can put the commas in, just hopefully they don't look like decimals. 1 plus, now what's the rate of interest? 6.5% or 0.065. And we're compounding quarterly. That means n is 4. The 4 there. And this is going to be raised to the power of 4t. Okay, so we're going to do it very similar to the previous problems. We want to get that variable by itself. So divide by the 12,500. And we're going to get, it was 1.6. So that was nice, 1.6. And then this, I went ahead and did this. A lot of students do this. You don't have to, but they figure out this number, and that number turns out to be 1.01625. And we're raising that to the 4t. Okay, this is as nice as it gets until we have to change it to a logarithmic equation. So the book, I think they usually have you just go with natural log, but you could use a common log, but anyway. If I go with natural log, I can go 1.6, and I can go natural log 1.01625 to the 4t. Now, what happens is this exponent comes down from the power rule. So we can say natural log of 1.6 equals 4t natural log 1.01625. And you're trying to solve for t, okay? Now, what's kind of weird is that you're going to divide by 4, right? So the 4's will cancel. But this part right here, the natural log, is just a number. And so you're going to divide by that as well. And you're going to do that on the other side. And it looks something like that. Okay, so then those cancel, and you just have t. You can see that little t in there. So t is equal to the natural log of 1.6 divided by, now I'm going to put brackets around here because if you don't, I'm worried you'll get the wrong answer. You have to divide by both of those things, so you can just put the brackets in 1.01625. Okay, so you do all that on a calculator, and it turns out that t is about 7 years. So it said round to the nearest year, so there you go. All right, if you have any questions, you can email me, watch the videos, and let me know. Study. Good luck with the exam. You can do it. The good news is chapters 5 and 8, I think they're different from what we've been doing, so I think you might like those better, maybe. They're different at least. Okay. Have a great day.